Something that really sparked my curiosity. I mean, you are electron microscopy expert, and yet you were at NASA. I mean, what NASA
How
was
did
doing,
I get there?
And what NASA was doing with electron microscopy.
So I have to go further back then to explain the connection. I did my PhD looking at how air pollution affects the heart. And this was done 100 years ago, roughly. No, not quite, but long enough ago that it wasn't a known connection that air pollution exposure not only affects the lungs, but also the heart and the health of the human heart and the human circulatory system. So when I did that PhD, it was a bit of a niche topic. To do that, I used electron microscopy. That's how EM came into the spectrum. And I did that research at a time where EM was no longer the new fancy technique. It was already considered old, and at that point it was being replaced by the new kid on the block, which was confocal microscopy. So I did research on how air pollution affects the heart using electron microscopy. Partway through my PhD, I learned about this school called the International Space University, and I was curious, and I applied, and I took 2 months off my PhD, and I came to Europe, to Strasbourg, France, and I was part of the program in Strasbourg. And there I learned that NASA was very interested in how lunar dust affects the human body. And the method of research between air pollution dust and lunar dust is exactly the same. The source of the dust is much more interesting, of course, but the method is identical. So when I finished my PhD after the time in Strasbourg, I was invited to NASA to continue the research on dust toxicology using similar methodology. And there at NASA, we studied how lunar dust affects the lungs, the skin, and the eyes, as those were the predominant exposure sites during the Apollo mission.
So interesting. I mean, you clearly were the right person for the job, but is there a lot of other biology at NASA?
Oh, tons of biology. I mean, it was a really interesting community where space exploration pushes our limits for living of all things, from plants, organisms, how do you grow organisms or food in Martian soil, like the Martian movie. All of these different aspects are very interesting. How do we recycle water? How do we deal with the waste that we produce? How do we prevent colonization of our spacecraft by bacteria or pathogens? So there is a lot of biology happening at NASA.
Maybe can you give a brief introduction in layman terms of what electron microscopy is and why it's so powerful?
Oh, brief. This will be my
Very
challenge.
Brief. Very brief.
I love electron microscopy. Okay, so a brief introduction to electron microscopy. It's important to compare it to light microscopy. Light microscopy is done with photons, the light that we see. This lets us image to a certain level of resolution. And what is resolution? Resolution is the ability to see these two cups as two cups and not when they're close together as a single cup. So we have a limit that if they're too close, we can't distinguish them. With electron microscopy, we have changed our radiation source from photons to electrons, and this lets us see structures that are closer together with the resolution to distinguish them. There are two big categories of electron microscopy. There is scanning electron microscopy, where we look at the surface and we scan a beam. And then there's transmission electron microscopy, where we essentially we shine through a sample and we're looking at the shadow underneath. And those two techniques give us different insights, from surface structure to then like what's happening within the sample. The beauty, in my mind, of electron microscopy is you really see what you're looking at. So I might be studying a structure like the microtubules, but if I'm looking at a cell, I see all the other components. And this is very powerful because it lets us see context in a way that we don't always see in other imaging modalities.
But one thing that always strikes me with that, I mean, of course you can adjust the resolution, but the resolution is so much that even a very small thing like a cell looks like an entire universe.
Yes.
That's why you were generating so many data. But so I see the challenge of really trying to reconstruct something that yet is so small, but it looks so big at this level of resolution. But you were also mentioning that electron microscopy comes in very different flavors, but then you said also that you were using tomography. So what's good about tomography?
So everything we do in all kinds of microscopy will come down to what is your question. Mm-hmm. And I think this is such an important point that we can forget. We need to get enough information to answer our question, mm-hmm. but we get ourselves in trouble if we acquire much more information than we need. Mm-hmm. So by this, I mean, if you need to magnify a sample only enough to see the cup, mm-hmm. this cup, but I magnify it down to the point where I can see the dust on the surface of the table, mm-hmm. I will generate 10 times as much data. Mm-hmm. And I don't need this much data to just say there's a cup on the table. Mm-hmm. So we need to understand our question to really fine-tune the imaging we do. And this applies for all of it, even light microscopy. Sometimes you don't need electron microscopy to say, is there a cup? You could do this with a fluorescent signal. Yeah. But if you want to, for example, show a different kind of question, maybe you need to go into one of the other techniques. Mm-hmm. And that's what I love about running a core facility where we have all of it, is the user will come to us with a question and say, Erin, we want to study this. And I say, okay, excellent. First, we start with the cup, and then we go for the next step. You know, you can go into it stepwise. You can explore to the level of resolution that you need using the whole toolbox of microscopy that we have.
And I wanted to talk a bit about accessibility in a larger sense, mm-hmm. which is, you know, giving the chance to all types of scientists to, you know, enjoy science and develop science. So is it something you're passionate about, and how does it
impact?
Yeah.
So yes, for multiple reasons. So coming out of science in 2017, I fell from a horse and I crushed my spine in 3 places, and I have a spinal cord injury as a consequence. I don't feel anything from my knees down, and I have partial paralysis of my legs. This makes my days of climbing on a microscope over. I used to change the gun of the electron microscope, not so much anymore. But I can still do my job. I hope I can say, well, I can still support the scientists. I can still really contribute to the field. And I hope that becomes an example for others. And I can start to change the dialogue in the community, that people with disabilities, be they physical or be they also to a certain degree mental health or different ways of learning, they still have a lot they can contribute. So by being in the field and being open about my disability and just living it on a daily basis, I hope I start to model a change, that we can make science accessible for all people. And different people have different perspectives, and that enriches our science. You know, it's not just a cultural enrichment or a gender enrichment, it's also a life experience enrichment that we can bring to the field.
I was thinking, you know, in practical terms, do you see yourself, or do you, it happens to you that you think of, for instance, solution to practical problems when you know, people like you and with other types of disabilities need to really be able to be effective in the lab and you know, as productive as they were as, you know, non-disabled people. And if anything, even you see situation in which you are more able than other people with your now privileged point of view.
Definitely, I think when you have more experience, it doesn't matter what it is, you can bring more input and more perspective. So for example, I joined the VIB and I realized in all the stairwells, they didn't have railings on half of the stairwell, which I wanted to take the stairs. Movement is good for us, but I can't just take a stairs without a railing. So, you know, seeing little things like this and asking for support, asking for small modifications can really make a difference.